Hi friends, hope you are doing well. So in this video we will be talking about mean value theorem or MVT. We will try to prove it using the Rolle's theorem, and I will try to give a geometrical or a visual interpretation for the same.
So MVT, I will start with the statements. So let f be any function from say closed interval a comma b to r, and f is continuous. F is continuous on a comma b. F is also differentiable. F is differentiable in open AB. Then we can say that there exists a C belonging to a comma b such that the following holds, such that f dash of C is equal to f of b minus f of a by b minus a. This is the statement for the mean value theorem. Now let's see what it means in geometric, or let's just try to represent it in a graph. So suppose this is my f, okay, and this is my a, and this is my b, and if I draw a line from a to b, let my f be something like this. Okay, cool, fine, fair enough. Then I can find a c between a comma b such that the slope at that point is equal to the slope of the line joining the points a comma f of a and b comma f of b. So the slope of the blue line is equal to the slope of the red line. The slope of the blue line is equal to the slope of the red line. Yeah. Now we will try to prove this, but to prove we will make use of another theorem. It is called the Rolle's theorem. Rolle's theorem, which states that if f is a continuous function from a to b, of course it's open, no, a to b closed, and f is continuous on a comma b, and f is differentiable on a comma b, and f of a equal to f of b, then Rolle's theorem says there exists a C belongs to a comma b such that f dash of C equal to 0. This is Rolle's theorem. Now let me give you an intuition of what we are going to do. So we will draw the graph for MVT, and let's take a simple graph. This is my function f. So this is, I don't know, this is a, this is b, and I am going to draw a line, and suppose this line makes an angle theta. Okay, now if I rotate my axis, so this is my x-axis, this is the y-axis. If I rotate my axis about the origin by an angle of theta, and we have a new pair of axes, the blue axis, let me call that y dash and x dash. So this angle is theta. Then with respect to the new axis, we can see that y dash of f and at a, or let's say at this point, let me call, okay, now we can see that the y dash of the yellow point and the y dash of the green point is same if with respect to the new coordinate system, right? So this is y dash of the yellow point, and this is y dash of the green point, and they are same because this forms something of a sort of rectangle, which means now we can apply Rolle's theorem, right? We can apply Rolle's theorem and we can find a point C such that the slope is 0 but with respect to the new coordinate axis. So this is my point C such that the slope is 0 with respect to the new coordinate axis, or in other words, the slope is equal to tan theta with respect to the original coordinate axis, right? Because if we extend this line, this is theta degrees, and the slope with respect to our original coordinate system is theta. And that's it. We are done with the proof, because the slope of the line joining a comma f of a and a comma f of b is tan theta. So now we need a formula for rotation. So rotation, right? So let me get my axis and let's just take a point here that calls it x comma y. So which means if I draw the lines perpendicular to the coordinate or the axis, then this length is y and this length is x. Now let me rotate the axes with respect to with an angle of theta, okay, which means this is y dash and this length is x dash. Now from we can say this angle over here is theta, right? Cool, fair enough. Now we will use some basic trigonometry to derive an expression for rotation. First of all, let's look at this triangle right here. So we have a triangle, and this is theta, this is x, we don't know this, we don't know this. Then use trigonometry. We have k sine theta is equal to x, then which means k equal to x by sine theta, and we have tan theta is equal to p by x, or p equal to x tan theta, right? So we have this length as p, which is x tan theta, and this length over here, that is x by sin theta. Now we need a formula for the y component, or we need to look at the smaller triangle over here. According to my diagram, it's actually quite small, but yeah. So we have, let's just draw the triangle. This is theta and this is y dash, and we don't know anything else, but we know the total length. Let me take the red length is y. So if you subtract the red length minus x tan theta, we will get the hypotenuse, right? We will get the hypotenuse of this triangle, which means this length over here is actually y minus x tan theta, right? Let me mark that in the diagram. let's just do this length is y minus x tan theta, and from here y dash is kind of obvious, right? Y dash, what is y dash? Angle, we have y dash equal to y minus x tan theta into cos theta, right? Take cos theta inside, we have y cos theta minus x tan theta is sin theta by cos theta, so tan theta cos theta equal to sin theta, so we have y dash equal to y cos theta minus x sin theta. Now we just care about the y component, but for the sake of completeness, let us find the x component, right? So what is the x component? It will be x by sin theta, which we have already found from our previous discussion, plus we have y minus x tan theta into sin theta. Now this will ultimately simplify to y sin theta minus x cos theta. So we have a formula for rotation. Let me just write it down. Have y dash, or should I call it y dash, because y dash can okay, let's call it y dash. Y dash is equal to y cos theta minus x sin theta. Okay, this is rotation formula, rotation. Okay, now what is theta? So now we apply our logic. This is our function f, oh my god, f of x, and that looks like a delta, but that's an f. A, that's b, and this is f of a, this is f of b, this is f of b minus f of a, and this is b minus a, and this theta, we can calculate what is sin theta and cos theta. Let's just call this length k for instance. So what is sin theta and cos theta? From this we have made, I will write it here, sin theta equal to fb minus fa by k, cos theta is equal to b minus a by k. Now we need to use the rotation formula, right? So we have y dash equal to y cos theta minus x sin theta, and what is sin theta? Sin theta equal to fb minus fa by k, and cos theta is b minus a by k. Now we will use the rotation formula at, I don't know, at the point a comma f of a. So a comma f of a. What is y dash? Y dash is equal to y, which is f of a, into cos theta, which is b minus a by k, minus sin theta minus x sin theta, x is a, into sin theta is fb minus fa by k. And what is this? Let me just simplify this. So let's open the brackets. F a into b minus af of a minus af of b plus af of a, the whole divided by k. We can see that af of a cancels, and we are left with bf of a minus af of b by k. So this is the rotated formula. So by applying the rotation formula at a comma f of a, we get y dash is equal to, we will call this y dash a is equal to bf of a minus af of b by k. Now let's apply the rotation formula at b comma f of b. So we'll call that y dash of b equal to fb into cos theta, right? Cos theta is b minus a k minus b into sin theta, which is fb minus fa by k. Now let me just simplify this a bit further. We have fb into b minus af of b minus bf of b plus f of b minus bf of a, right? Okay, did I miss something? No. And these two cancels, and let me just rearrange them. We are left with bf of a minus af of b by k, right? And that's the same thing as this. These guys are the same thing. Now we just have to apply Rolle's theorem. So let me just draw what we have done till now. Draw. So if our function is something like this, and so our line, we have these guys, that is the red line. The red lines are the same. The y dash is the same. We don't care about x dash now. So since y dash is the same, with respect to the blue coordinate system, we can apply Rolle's theorem, and by Rolle's theorem we will find out that there exists a c which will lie somewhere over here according to my diagram, and such that the slope is equal to 0 with respect to the new coordinate axis. And if y, that's the same thing as saying the slope is equal to tan theta. Theta is this angle, or the angle joining angle of inclination of the line joining the points a comma f of a and b comma f of b, and that's it. To find c, you can just use the rotation formula again by putting theta equal to minus theta, and yeah, that's it. So we'll get this point if we do that, and that is the value of c. So hope you get a understanding of the proof. In many textbooks you will see to consider a function f of say phi of x equal to f of x minus f of a minus fb minus fa by b minus a into x minus a, and then put the values a comma b, and you will find that psi of a equal to psi of b. But this is actually the same thing as our rotation formula, but you just need to work it out a bit to figure out why they are literally the same thing. And that's it. Hope you guys enjoyed. That's it. Hope you guys enjoyed. Thank you.